So again, welcome to the International Water Resources Association webinar for Sustainability of Engineered Rivers and Arid Lands, SERIDAS, Response to Critical Challenges. So our panel today includes John Berggren at the University of Colorado in Boulder, United States of America, Aysegül Kibaroglu, sorry, MEF University in Istanbul, Antonio is not with us. We have Eduardo Sávio, the Research Foundation of Meteorology and Water Resources in Brazil. James E. Nickum, the Water International Editor-in-Chief of many years in experience. Jurgen Schmandt, the University of Texas and the Houston Advanced Research Program at USA. And Stephanie Glynn, Program Director at the Houston Advanced Research Center. There in Texas as well. So as most of you probably know, this is a webinar hosted by the International Water Resources Association, and the IWRA is an international network of researchers and practitioners who work on a multidisciplinary range of water resource issues. We are a nonprofit, non-governmental educational organization, and we're celebrating our 50th anniversary. So we've been around for quite a number of years. The IWRA, we provide a global knowledge-based forum for bridging disciplines and geographies by connecting professionals, students, individuals, corporations, and institutions who are all concerned with the sustainable use of the world's water resources. So we're really happy to have you here today, and we thank you for tuning in. We have, like I said, a great panel who have really been working, not just in the field, but they've been working together. And I think that's something that's unusual. You know, many of our webinars bring together people from diverse backgrounds who've never worked together perhaps before. But here we have a panel of people who have been researching and working together for quite a long time. And that's something pretty special, I think. So we're kind of looking forward to seeing that kind of dynamic come out. So as I mentioned earlier, this is the second webinar on the sustainability of engineered rivers and arid lands, the SERIDAS project. So last September, we discussed the current emerging problems faced by 9 different rivers and continents, and questions like loss of reservoir volume because of sedimentation, reduced water supply due to climate change, and continued use of inefficient irrigation. So all these issues really threaten food production, which is important, and the urban water supply and the protection of the environment. So today we're going to look at a different flip on that. We're going to take a look at the responses. How should we respond to these kind of challenges that came up? So how should managers and users of SERIDAS rivers respond to these reduced water supplies and yet still be able to keep and maintain and restore the sustainability? We're going to talk about 2 different strategies. We're going to talk about stakeholder participation in river management, and then the carefully planned interbasin transfers. So we're going to look at 2 of these different rivers, the Yellow River, which is in China, and the Colorado River, which is in the United States. So we're going to then kind of bring it back around and look at a new definition of SERIDAS of river sustainability, and look at how governments and river managers should carefully determine the river's dependable yield, even under drought conditions, use the result of negotiations and water allocations with the users, and to draft and regularly updated river sustainability plan. It's a lot to cover in about 90 minutes, so I hope we can do it. I'm just going to make sure I want to review the format of today's webinar. So to start with, each of our panelists are going to give a very short presentation of about 10 minutes long, and then at the end, we're going to save all your questions for the audience. And what you can do, just anytime you have a question, type it in the Q&A box there at the bottom of your screen there, and we'll see it. And I've asked all the panelists to be able to respond real quickly to you. If it's a small and easy to solve question, hopefully we'll get it knocked out right away. So you can keep the questions just right there in the Q&A box. You know, pose them at any time, and then we'll have them posed to the panel afterwards. And of course, we always have the chat box as well for you to chat between yourselves. So we are going to also, as it reminds you, record the session. And so we'll have the session recording and the webinar slides, everything up on our website, www.iwra.org, within a couple of days. So we have a lot to cover today. And with all of this prepared, I'm going to turn the floor over to our moderator, Stephanie Glynn. Stephanie, the floor is yours.
Okay, great. Thank you so much, Scott, for that great introduction. I appreciate it. We're all very excited to be here. As Scott has said, we have been working on SERIDAS for a number of years, and I am going to give you just a real brief overview. Scott, will you let me know if you guys can see that okay? Thumbs up. Does the screen look okay? Just a brief overview of SERIDAS itself and how we started. We started with a grant a long time ago, over 10 years ago, where we convened a Mexican and United States team. And the focus then was looking at water supply and demand in the lower Rio Grande, which is in the United States. Over here on the left, you can see it on the map, the Rio Grande River is highlighted. This map actually shows all of our SERIDAS rivers that we eventually ended up with. But during that time and discussion, we had a lot of focus on questions of, is the lower Rio Grande Bravo, is the demand and the problems and the challenges that we saw with that, is that representative of rivers elsewhere? And what are the prospects for engineered rivers in arid lands worldwide? And how will those rivers respond under the impacts of climate change, sedimentation, and population growth? And from those questions, SERIDAS, the sustainability of engineered rivers and arid lands, arose. These are the rivers that we're focusing on. So in the United States, it's the Colorado and the Rio Grande. South America, it's the Limara and Sao Francisco. Moving on over to the European and African area, we have the Car, Euphrates, Tigris, Nile, Yellow, and Murray-Darling. What we were looking at originally is the starting point of 30% less river water by 2030. What would that mean? Specifically, we started in this area, Rio Grande and Northeast Brazil, with those three impacts that I mentioned earlier. What does it mean for climate change, population growth, and reservoir sedimentation for these rivers? Here's some facts about each one of those rivers, their length, the basin size, irrigation, which is big in all of these rivers, and then their annual discharge. I believe that was factored in as of 1980 to 2000, maybe the average. The project team completed the phase 1 of this project in a meeting, well, 3 meetings really, but the beginning one was in Austin, Texas in 2014. We discussed how we were going to do it, our study methodology, the rivers we were going to bring in. We really wanted to focus on past and current river conditions. And then we also had some kind of specialty focus areas that overarched all the rivers. And those ended up being specialty chapters in the book that we'll be discussing. These were things like inflows or groundwater. And we had some detailed discussion on that in the webinar that Scott mentioned earlier in September. So if you're interested in a lot of things here today, we really encourage you to go back and look at that webinar as well. Lots of good information in there. We had another workshop in 2015 in Hanover, Germany, and a third and final one in Bellagio, Italy in 2017, where we really discussed and focused on these rivers, these impacts of the climate change, the sedimentation, and the population change, and what it would mean now and in the future for these rivers. Our team includes an expert for each of the rivers that I mentioned, as well as those specialists for the key change factors. The book is going to be published by Cambridge Press. It is supposed to be published any day now. I'm going to say the summer of 2021, keeping in mind, I believe that ends September 20th. And so it might just be in the early fall, but we're hoping any day now we'll hear news on that. And so the common features of our SERIDAS rivers, and you're going to be hearing a lot about these themes today. They're all engineered. They have large reservoirs, they have distribution channels. They have human needs that depend on these rivers for sustainability, flood control, food production, drinking water, energy production. In terms of nature, they all get their water from snowpack or highland rains. They depend on spring floods, for fertile soil. It's an arid or semi-arid climate downstream and highly seasonal stream flow, some so seasonal that there's actually issues with inflows reaching the end of the river annually in some of these areas. So the hypothesis we started out with is that this system that we're looking at now globally of engineered rivers is going to collapse due to climate change, sedimentation, and population growth unless river authorities can stop using the rear view mirror. In other words, don't plan for the future based on what you've seen in the past, because climate change impacts do not follow past data responses, past historic responses to the basin. We need to see a proactive sustainability plan, and it needs to be developed basin by basin. The stakeholders in the watershed have to become the management partners. We need to talk to them to figure out what the problems are in their area, and we need to have an integrated approach to management. And then we need to look at the focus of dependable yield becoming the measure for basin sustainability. The response, and you will be hearing about some of these things today, but all of these are under discussion for responses to each of the individual basin. They all present kind of their own problems, challenges, and solutions. And some of that you'll be hearing about today. Some of that we discussed in the past webinar, and they're discussed at length in the book as well. So as that was just a brief overview of SERIDAS itself, how we kind of came to where we are, and a little bit about what you're going to be hearing today. So I'm going to stop my screen share, and Aysegül, I believe you're up next.
Sure, great.
Okay. So as Scott mentioned, this is Aysegül Kibaroglu. I'm going to mangle it too, and I'm so sorry. Kibaroglu, say it for us, please.
Aysegül, it's a challenge, really, Stephanie.
Yes. Coming to us today from Turkey.
Yeah, thanks a lot. It's great to be among friends, and welcome all the participants. Great to see you all, that you're interested in our project. So I'm going to share my screen. Yeah, I will be talking about the book, one of the chapters of the book, but just to focus on certain country like Turkey. So the book is mostly about the rivers, but there are also themes that Stephanie already mentioned that we focused on, and stakeholder participation was one of the major themes we tried to focus on and understand how we can make it really possible in order to reach sustainability in SERIDAS rivers. So this is the chapter that we co-authored with Jurgen. It's about stakeholder participation. And we found out that current stakeholder participation represents a very mixed picture in SERIDAS rivers that we mentioned, the 10 rivers. So inspired from this chapter and from my years-long observations, I will discuss today shortly the role of irrigation associations in Turkey's water management. So it's one of the stakeholders, major stakeholders in all SERIDAS rivers, the irrigation districts or the irrigation stakeholders, and this will be the case to focus on. And yeah, starting in the 1960s, countries or geographies as varied as Taiwan, United States, began to turn over the management authority for irrigation systems from government agencies to the farmer user groups. And management transfer has taken many forms, ranging from complete privatization or under the term of participatory irrigation management, where responsibilities are shared between public sector and the water user groups. And according to FAO, at least 50 countries since 1960s have implemented some kind of national irrigation transfer program. And the 50-year history of participatory irrigation management gives us vast literature, vast experience in the form of case studies, impact assessments, qualitative reports, and a variety of implementation guides for decision makers. Case studies such as Turkey form the building blocks of our knowledge regarding PIM, the participatory irrigation management effectiveness. Turkey has been one of the front runners in irrigation sector reform, and the almost full transfer of irrigation systems to water user organizations, namely the irrigation associations, dramatically empowered irrigators in the sector. And those irrigation associations have helped them to overcome some problems like collecting the irrigation fees or operating the systems. However, they haven't shown any significant change in irrigation efficiency. And there had been also problems about decentralization, particularly the effect on participatory performance of these irrigation associations. So how did it start and when did it start and why it started that the Central Water Agency decided to turn over the responsibility of management, operation and maintenance of these systems to the water user groups in agriculture? DSI, the Turkish acronym for State Hydraulic Works, is the Central Water Agency under the ministry, which actually develops and manages the water infrastructure in Turkey. They had an entitled law to make such possibility that they can hand over such responsibility to the farmers. And since 1960s, this has started. However, this process of management transfer gained momentum in 1990s. And this is not a coincidence that it was the start of the liberal movement in water management, and it was very much championed by World Bank. And there had been really close relations between World Bank and Turkey to start this new momentum. So what were the motivations and the key background conditions for such a large scale transfer, like almost all of the irrigation management to the water user associations? Well, the key background condition was that the Central Water Agency had a budgetary crisis, and there were financial restrictions in its budget, and there were also deteriorations in the irrigation infrastructure. So the idea was to transfer the management and operation and maintenance to the water users in irrigation so that they can manage better their financial affairs and also take care of the canals. However, after almost a quarter of century of experience, there are pros and cons in this stakeholder involvement in irrigation in Turkey. The pros is like that the almost full transfer of irrigation systems to the associations have helped to overcome some problems such as collection of fees. And this was a great support to DSI, which was in crisis in budget. However, the cons has been, as I mentioned, water use efficiency still remains as a challenge. And when we observe the experiences of participatory management, we have seen mixed results. So what do I mean by mixed results actually is that first the efficiency and economics, after the transfer, there had been great improvements in collection of the fees from the farmers. So the irrigation associations have been doing much better than DSI in collecting the fees and operating the system to some extent. So we can say that the economic target has been achieved in the first decade especially. But when it comes to efficiency, the researchers found out that there wasn't much improvement. And when it comes to participation, the results were more mixed. Some associations were unable to implement participatory management in some local contexts, especially characterized by power asymmetries, like in geographies in Turkey, in southeastern Turkey. And on the other hand, in some other contexts, participatory irrigation has been achieved. So there had been co-management of irrigation, especially in drought times when the Central Water Agency and the association managed to devise a new management payment mechanism to reduce the amount of irrigation without endangering the crops. So my observation is that after a quarter of century of actions in the irrigation associations, a whole of Turkey study on the participatory performance of them is absolutely necessary. There had been great changes lately in the legislation procedure of the associations. And first, the associations were created in an accelerated transfer program without special legislation. So they were created based on the local laws like village law or municipality law. And then they achieved their specific and also independent structure with the initiation of the law in 2011, which gave them empowerment in terms of electing their representatives, especially the chairperson, and also executing the functions, administrative functions and technical functions. So there had been an improvement in a decade or more than a decade time that the irrigation associations achieved a specific law that gave them more independent structure so that they can achieve also participatory irrigation management. But lately, in 2018, with a new law issued by the government, the new government under the presidency, the law again changed, and the the irrigation associations started to be appointed, the chairpersons started to be appointed by the minister upon the suggestion of the Central Water Agency. So this put strictly back the control of the Central Water Agency back on the irrigation associations. So what we have achieved, what we have arrived after years of experience is that the irrigation associations came under severe criticism by the government, successive governments of the same party, and with the new law, the government also declared that there is huge corruption in the management of the irrigation associations. So they put back the control of the administrations in the hands of the civil personnel from the Central Water Agency. So we can discuss the reasons, but the major reason was that the government was concerned about the corruption and inefficiencies. On the other hand, the researchers also figure out that there had been problems about efficiency of water management, as I said, and there had been problems about how to allocate water most efficiently on farm level. Yet this rollback process was really disappointing because Turkey started as a front runner in terms of decentralization, but nowadays almost 200 irrigation association chairpersons come from civil servants of the Central Water Agency, and they cannot abolish themselves, only the ministers can abolish. So anytime the ministry can abolish any irrigation association. So there are controversies and concerns between the stakeholders, namely the farmers, irrigation associations, and the government. So my conclusion is that after this bit confusing case, that the Turkish case of devolution demonstrates that a broader consensus among stakeholders, namely the farmers, the associations, government, civil society, and academia, becomes absolute necessity for any reform to make positive impact on especially equity and efficiency in irrigation management. So thank you very much.
Let's go, we appreciate it. Turkey's always been a really, really difficult one to figure out. And every time I read the draft of your chapter, I think I'm close to understanding it. And then I realize I'm not.
Yeah, continuous change, yeah.
Yeah. Okay, I wanted to mention again, because I saw a couple people with hands up, that Scott had said we were going to take questions at the end. So if it's something you don't want to forget, please drop it in the chat and we'll have questions then. Okay, so next up is Eduardo Sávio. Eduardo, are you ready?
Yes, I am.
Okay. We look forward to him. He's speaking to us this morning from the Research Foundation of Meteorology and Water Resources in Brazil.
Okay, are you guys seeing my screen?
Yes.
Okay. First of all, thank you for the invitation to speak here. I want to make sure that all authors are recognizing my presentation. So I put here Magalhães and also James Nickum that collaborate in the China section of the book and reviewed the whole document. Thank you very much, James. So first of all, we're talking about engineered rivers. So I tried to get a picture of how modified are the rivers around the world. And I got this nice work done by Global Hydro Lab that shows by using two indicators, river regulated index and river connectivity index, that demonstrate how river is fragmented and flow is regulated throughout the world. So we can see how modified are the rivers and basins around the world. So it's nice picture of the engineered rivers problem that we are trying to address. And one of the motivations to look into the interbasin transfers was, well, this was a challenge that Jurgen posed to me and Magalhães to write a chapter on that. And we decided that, well, what would be the motivation question for us? And looking at the Brazilian case, we see that much of the difficulties that we face and in dealing with water crisis in Brazil is the strong emphasis in the infrastructure. And looking around the world, it seems to appear to to be a commonality in other interbasin transfers projects. So in also other common issue, people don't look very closely to the climate information that is available already in the future scenarios. So you always look to the past, as was mentioned before, and this is something that we need to change in water management planning. And there is a lot of pressures for water transfers. We are now the San Francisco River Basin. We're not finished the project yet. It's a 12, 15-year project, and it's not finished. And people is already coming up with new water transfers for the same region. So this is some challenge. Why not to work on the issues that we have in the recipient basins? For example, demand management, water recycling, and before thinking about water transfers. So this is kind of common in all case of studies that we look into, almost all case of studies. So this is something that we need to advance in order to properly address the better water management practice in this case of studies. So one of the things that people try to defend is the need for more water. But for example, in cities like Fortaleza, we have 40% of losses, water loss in distributed systems. So in 10 cubic meters per second, you lose 4 cubic meters per second for the whole city of Fortaleza. So it's in this value, it's basically what we are transferring from the San Francisco River Basin to CRI state. And so why not work better in reducing the loss in urban areas and also water savings practice in the agriculture irrigated project, for example. And also one other issue that we investigated in all these case of studies was the main driver for the interbasin transfers were the new agriculture projects. In that sense, it's important to assess the economic viability of the agricultural practice in the proposal recipient basin. And this is something that this kind of studies are not carried out in any of these studies, case of studies. So the book chapter analyzed several cases of interbasin transfers around the world. The first one is the Colorado Big Thompson project in the United States. The second, Chavomiki, Peru. The San Francisco River Diversion Project in Brazil. The Trasvas Daulis Santa Helena in Equator. Pagos Segura Transfer. El Salam Channel in Sinai, Egypt. The Lesotho Highlands water transfer to South Africa, and the South to North water transfer projects in China, and finally the Snowlin Mountain Hydro Project scheme in Australia. So we have quite a good set of case of studies that covers several continents of the world. I would say all of them, yeah. So we have a big picture, what happens, what motivated the diversion projects, what were the advantages and the disadvantages of each approach that was taken in each case of the diversion projects that we analyzed. So what then would be a path toward interbasin water transfer? First, before considering the interbasin water transfer, we have several alternatives that we should try to implement before, like reducing water demands, reducing losses in the water supply network, as I mentioned before, increasing water use efficiency for domestic, urban, and agricultural water uses. and also education programs, recycling wastewater, supplementing water supplies locally, restoring traditional water management structure, desalinization, as examples, and so on. Reviewing policy and regulations. This is something that we do not pay attention very much here in Brazil. We are now trying to improve the system, but still it's a challenge, changing the law, implementing those new instruments to have a more effective water management policy. Using the water management instruments to promote efficiency, implementing conjunctive use of surface and groundwater resource where possible, and then considering the interbasin water transfer. So there is a lot to be done before considering the interbasin water transfer. I understand also, and we recognize that in the book, that maybe the political capital is there at that particular moment. So there is no order to follow in these initiatives. And in this sense, I think that some decisions may on water transfers may become first than those alternatives that I mentioned before, because of the political capital that is in place. So in summary, the name of the chapter is Intelligent Water Transfer. This was a suggestion by Jurgen. And in summary, what would be the intelligent water transfer? Should be implemented in the context, more general sustainable development strategies and integrated water resource management. Also, we need to engage a negotiation between donor and recipient stakeholders, and agreement should be reached previous to the construction of the projects. And this is not always the case. However, one should also consider the political momentum, as I mentioned before, for the water transfer decision, which may not be favorable in the near future. But what we see now in many cases is a quite recommitted to big infrastructures. And the discourse now is being used is climate change, green projects, and so on. So in my view, some of the new projects are using climate change as a scapegoat for justifying the need for supply augmentation. And we have to watch for that. I mean, the analysis should be more thorough in terms of the sustainability of the donor base and also the impact that we're going to have on the local communities. And when you look on water governance, what they are moving the scale of the governance. Now we are moving towards a regional scale of water governance, and the local impacted communities are not heard in these large scale systems. And we have to take care of that, trying to come up with a polycentric system of water governance in order to establish a communication between regional scale and the local communities that eventually will be impacted for those big infrastructures. Thank you very much.
Thank you, Eduardo. The intelligent water transfer. I've always loved that that title. Hopefully we can get there, right?
Yes.
All right, next up is James Nickum, coming to us from Water International in Japan. And thanks, James.
Yep. Oh, thank you very much, Stephanie. I'm glad to be included in this. I was actually kind of a latecomer to SERIDAS and at the third meeting. But I was asked to take on a little case study called the Yellow River, and I'd like to just give you a quick. And 10 minutes is not a lot of time. I hope I can even keep this within it. I'm also following. There's an old Chinese saying that one picture is worth 1,000 characters, which is about 500 English words. So I'll focus on pictures and not so much on words. Okay, let's see. That okay? Do you see that?
Yes.
Oh, okay. I have two screens, so I'm not quite sure. All right, so we originally just called this what the chapter in the book is, the Yellow River, but Scott said it had to be more, so we added sustainability as dialectic, which makes it sound very Chinese. Okay, so there are a lot of SERIDAS rivers. Actually, you're not seeing much mention of these, but among those, Stephanie showed a little bit of where the Yellow River fits. In length, it's the most similar to the Nile. It has a modest discharge considering how long it is, and it's actually not concentrated in the spring like perhaps the original cases. It's concentrated in the summer, as with the Nile. Both are significant silt conveyors. In the case of the Nile, that actually provided the basis of agriculture in Egypt. In China, you see that has a somewhat different, yes, and the area under irrigation is similar. But it's also similar to the San Francisco, which is has a similar kind of basin area, and it's only in one country. So at least one thing you don't have to worry about is the kind of the international dimension. Now, in thinking about this concept though of sustainability as dialectic, the point is that solving one problem through engineering or anything else often leads to another. And that's certainly true of the Yellow River. Flood control by diking leads to an increased catastrophic flood risk if it's a silt-laden river. Withdrawals for human use upstream endanger the supply downstream if it's an oversubscribed river. But if you reduce the silt in the river and as well as the water, then you lose the delta. At least in the case of China, where the natural tectonic processes are actually for the coast to collapse or to subside. Mainstream rivers can affect the river regime, but they can also be operated to address some sustainability concerns. And conventional engineering is of limited use in erosion control, but in the case of the Yellow River, erosion control is has historically been possibly the most important element. The three reaches of the Yellow River, by convention, it's divided into upper, middle, and lower reaches. Each of these have different characteristics. Again, we don't have much time to explain this except to note in the upper reaches where the rain comes from and the runoff, and also I think the glaciers. But the silt comes in the middle reach, which is not as long. Population is relatively light in the upper reach. It's only 30 million people. In the middle reaches, it's 80 million. Lower reaches is very short, very narrow catchment, not much runoff, not much silt contribution, but it goes across a very flat land, the North China Plain. And there, the population is only 13 million within the banks of within the dikes of the Yellow River, which is its catchment. And about 55 million more people are served by the water of the Yellow River by diversions. Okay, so what does that look like? Here's the picture, one picture. This is a kind of a conventional one. You see that it takes up a good portion of China, actually. And it covers several provinces that are marked here with these. The river itself is in blue, and it's a little hard to see, but it kind of comes together here in the headwaters, goes through here, goes through some major irrigated areas along here, and then get to here. And that's where the middle reaches start. From the middle reaches, it kind of turns south, shoots straight down, more or less, through a very cultivated area, has two major tributaries, and picks up a lot of silt. The lower reaches start about here, and that's kind of a straight shoot to the sea with very minor tributaries. And this is, as we'll see, because it's held in place. So one way to get a good sense of this, I think, is just to go to the maps, which Google kindly provides, and look at it. I won't give you the source areas, but this is the largest reservoir. It's the first big reservoir, and it's the largest reservoir on the system. It's followed by a smaller one, and then it's followed by another large one. So those are the upstream ones. They're primarily for power generation. Then it moves on down, and here you see the large irrigation districts in the upper. This is still called the upper reaches. Very much desert kind of landscape on either side. The precipitation here, it's semi-arid. It's around 250 millimeters per year. Then when it turns south, it goes like this, and you can see we're beginning to get some population here, some settlements. Goes down this way and then turns to the east. This is a major reservoir that was built in the late 50s, early 60s, called the Sanmen Gorge Dam. Over this way is the tributary with Xi'an. This is a close-up of when it goes through the List Plateau. It's the world's largest List Plateau, yellow soil plateau. And you can see the problem here. There's virtually, it's like there's no control on erosion in this whole area. So what you have is a lot of very friable soil, which was originally wind driven, just pouring into the river. There are some check dams here, reservoirs, a lot of smaller ones. They're pretty much silted up. Then you go downstream to the large downstream reservoirs, and right at the end of where, before it goes into the plain, there is a very large one. It is the newest one, and the second largest one, the Xiaolangdi. Downstream, you see that it kind of squiggles across the landscape. And what you don't see here is that almost this whole area, it is between dikes. And those dikes can be quite wide. I've got 1997 here near the city of Kaifeng. We'll come back to that. Okay, so why is it narrowly constrained? Because out there on the plain, if the river is allowed to do what it wants to do, it will continue to build the plain. It will flop all over the plain. It'll drop its silt. That's good at plain building, except that people want to live there. So for the to-do list in civilization, the number one was flood control. And there's legendary Yu the Great, second emperor of China, I believe, and he's the legendary first engineer of the Yellow River. It's about 4,300 years ago. So I don't know how that compares to the Nile, but that's the only one that I could think of that would have the longevity record. This is a diagram, making the Yellow River look like a dragon. So you can also kind of think of the history of the Yellow River control as a struggle between people and the dragon representing the river. Now, here's a picture of the dikes that I took on my first trip to China in 1974. You can see how wide they are, how much space they give the river to operate in. In fact, you can't really see the opposite bank. It's probably about 10 kilometers away. You can see on the main stem there is a traditional Chinese junk that's floating. This riverbed is higher than the surrounding land outside the dikes throughout almost the entire stretch. In some places, it's up to, I think, at least 10 meters above the surrounding land. So you see, if the dikes are breached, you've got a problem. Here's a new modern engineer, just showing off some of my old photographs. Then the river continues across the North China Plain, again between dikes, so that actually the Yellow River in the dike area is the watershed for the two sides on each side. This is the high river, this is the Huai River. The Yellow River just flows through until it gets to the delta. Here's the delta. In this area, the river is allowed to kind of move back and forth. It was up here not so long ago, now it's down here. And you can see even in this area, there's a lot of human activity. A lot of, I believe, fish farming, salt collection, and one of China's major oil fields. 1997, go back to that. That's for about 25 years, the Yellow Rivers was affected by droughts already, not the climate change we're talking about, more INSO droughts. And often after 72, it did not reach the sea in the wintertime, the dry season. In 1997, it was the kind of record. It reached the sea for only 35 days. In other words, there was no flow to the sea for 330 days. And at one point in that time, it ran dry 703 kilometers from the sea, which is roughly where I put that 1997. In other words, mostly the lower reaches were dry at that point. So that raised the question, sustainability alert. Is the Yellow River's flow sustainable? I mean, this is kind of like the nightmare scenario, SERIDAS 30 years from now or 50 years from now. Well, it's been done in China. Here it is. And organizations like World Watch were talking about the drying of China, and it's going to make put world food security at risk. Actually, the article turns out it's not about the Yellow River at all. It's about the drying of China and about the overdrafts in the North China Plain. But this shows you the kind of the symbolic importance of the Yellow River. Well, what happened after 1997? That's only what, about 24 years ago. The Chinese is, as you probably know, is a centralized system, although it's not exactly like Beijing says something and it happens. There's always negotiation, but the central government did try, even as early as 1987, they set a quota system for how much water each province could take. That's at a very high level. Some of these provinces, I think one province has got over 100 million people. They also ensured, they adjusted that quota system because it had been set in wet years. So they made it more flexible and they adjusted it downward so that every year they could adjust the quotas. Then they put some teeth into it with a digital monitoring system. And then they also made it an overriding objective of the river engineers to keep water flowing to the estuary. So they would manage like the reservoirs throughout the river. They also built that last reservoir I showed you, the Xiaolangdi, which can be used to regulate, it's primarily to regulate silt and to prevent floods, but it can also be used to ensure a minimum flow. All that worked. The river now flows to the sea, although again, not often not enough to cover the levels that have been established as what would be desirable for an environmental flow. Now we have here a picture, a description of the calculated natural discharge over time. It's fairly flat since the 70s. But the observed discharge, and this is down towards the delta, the last station before the delta, it started to go down. You could see the effects said after 72, you started to get a distance here. And then this is 1997. After 97, there's a little recovery, a slide again, but in the 21st century, there's been some flow, still a lot not. So the natural runoff plus observed is equal to the observed runoff plus consumption and changes in reservoir storage. So that's where you get the human effect. So the Chinese have been studying and there's a huge amount of study on the Yellow River. It's policy oriented and doing a lot of the actions in terms of these kinds of things. The natural runoff has declined, but this is like over the span of a century. But the thing that is the surprising thing in the 21st century is that the mean silt load has gone from, at this point, the Yangtze River was clearly the siltiest river in the world, probably in terms of it was rolling mud during the summer. And that is now down to roughly 1/7 of what it was, or it was, that was the average even in the 21st century. It's continued to decline. How did it happen? Where did the runoff, and in particular, where did the silt go? Well, it stayed up there in the Loess Plateau. Why? It's a bit of a guess, but they think that one of the conventional way of doing it was the check dams, but most of those are silted up. There's more terracing by farmers, but most of all, it seems to be the effect of trees and grass, biological cover. There are other possible factors such as groundwater abstraction. Is this for good? Is it dilemma solved? You know, if we're taking care of at least that part of the sustainability? Well, some engineers say no, because floods could come along and, you know, make everything, you know, there are historical floods that could do that. They point to the fact that there's not much room for more impoundments. But my co-author, Zhao Xiaofeng, who couldn't make it here tonight, I think, he says, yes, it is sustainable. He's known as an incurable optimist, I think, sometimes. He says that this vegetative cover can actually continue to be expanded up to something like 80%, 90% of the cover, because, you know, the population, this is one of the good things about urbanization and movement of population. People are moving out of the marginal areas. They're going to the city, or they're sometimes being moved somewhere else. Well, okay, I've probably gone way over my 10 minutes, but I haven't seen the cane come from Scott, so it's okay. But so I say we left out most of the story of the Yellow River sustainability dialectics, and if you want to know what we left out, read the chapter. Thank you very much.
Thank you, James. We appreciate it. It's always fascinating to hear about politics and geology and everything that has to do with the yellow. I would encourage everyone out there to read that chapter. It's a great one for sure. And we're super glad that James could come on board and join the team. Next up, I believe, is John Berggren, who's coming to us today from University of, is that correct? John's next? Yeah, University of Colorado in Boulder.
James, if you can unshare your screen, then I can share mine.
Yes, James, can you unshare your screen? Here we go. Thank you.
That look good?
Yes, that looks good. Thank you.
Awesome. Thanks, Stephanie, and thanks everyone for being here. I've been a part of this project for the last 4 years, and so long, and so that I'm actually no longer with the University of Colorado. I was there as a grad student when I started with this project, and my advisor, Doug Kinney, is the co-author on this chapter. But since then, I've actually graduated, and I'm now with a conservation group called Western Resource Advocates. So just shows the longevity of this project, but happy to be here. And I'm going to be talking about the chapter that I helped write for SERIDAS, which is on the Colorado River Basin. And similar to the James chapter, the chapter title is just Colorado River Basin, but for this webinar, we want to think a little more critically. And so what I came up with was the transformative change through incrementalism. And I'll get into a bit what that means here in a little bit. So like I said, I'm with the Western Resource Advocates, conservation nonprofit based in the Western United States. There's our website, and I won't spend much time on that. So our chapter is on the Colorado River Basin, which is located in the Western United States. It The Colorado River and its major tributaries start up in the Rocky Mountains up in Colorado and Wyoming, flows down through what's known as the upper basin states, which is Wyoming, Colorado, New Mexico, and Utah, where it enters the second largest reservoir in the United States, Lake Powell, and then it moves down into the lower basin, which is the lower basin states of Arizona, Nevada, California, before entering the #1 largest reservoir in the country, Lake Mead, and then it gets distributed to those lower basin states, and then eventually ends up crossing the international border and entering the 2 Mexican states of Baja California and Sonora, before historically it would reach the Gulf of California and actually reach its delta. And as I'll get into, it actually hasn't done that with any regularity in decades, and that's one of the fundamental challenges for this river basin. One other thing I wanted to highlight is this black line delineates the hydrological basin for the Colorado, but these red hatch marks are the areas where those interbasin transfers move water out of the Colorado River Basin to other adjacent river basins where it is actually used primarily for agriculture and municipal supplies. So as Eduardo mentioned, there's an interbasin transfer up here in the headwaters. The Colorado Big Thompson project moves water from the headwaters of the Colorado to this big red hatched area on the South Platte River. And that's one of the major features of the Colorado, is how much water is actually moved out of this basin. So the fundamental challenge for the Colorado River is, as we've seen in many of these river basins of the country, is over allocation. There's more water that is used than is physically available, and there's plenty more water on paper rights than is physically available. And so this chart kind of highlights that in one relatively easy to understand graph. This yellow line is the water use on a 10-year running average going back to the 1920s to roughly current, and then being projected out to 2060. The blue line is actually the supply, and again, same time period. And you can see a lot of variability. The Colorado River is a snowpack driven system, and that snowpack varies quite a bit year to year. And so you get these huge swings in the flow of the river. You know, we've seen upwards of 20 million acre feet in some years, and as low as 12, 13 million acre feet in other years. Historically, that's been buffered by those 2 large reservoirs, along with a lot of other storage in the basin. So Lakes Powell and Lake Mead can hold approximately 4 years worth of annual Colorado River supplies. So even though there's this huge variability in annual flows, we've been able to still continue to increase our use because of those large reservoirs. Importantly, it's become what is known as a closed river basin. Again, it's over allocated, so supplies no longer meet demands, and you can see going forward, it's only expected to get worse. So this, the yellow kind of fuzzy part is continued increases demand. It's unclear how much demands will totally increase, but these are some of the fastest growing regions in the country. And so we will get some increase in demand, although it's unclear how much. And then climate change, which has impacted this river, will continue to impact this river. And by mid-century, latest climate scientists is somewhere around 20% reduction in annual flow in the Colorado River. So you have this mismatch in supply and demands, and it's only expected to get worse in the coming decades. And how this manifests itself to date is, I'm sure many folks have seen this picture. This is Lake Mead, again, the largest reservoir in the United States. And you can see these bathtub rings where over the last 20 years, due to climate change, over allocation, and some pretty severe droughts, we've actually drawn down this gigantic reservoir, hundreds of feet, exposing the bathtub rings of where the reservoir used to be. So this is kind of emblematic of the challenges we're facing on this river basin. Importantly, too, from a national context, is the Colorado River is incredibly important for the Western United States, for this region. It supplies water to upwards of 40 million people, over 4 million acres of irrigated farmland. But we've seen it's gotten so bad, it's actually garnering national attention. So national media is starting to grapple with what it means to have these extreme drought conditions. And from this New York Times article just a few days ago, you can see how bad the current drought has gotten, to the point where large sections of the entire Colorado River Basin are in exceptional drought. and it's gotten to the point where it's quite scary. We're potentially reaching unprecedented levels in terms of our storage, in terms of river flows. People are calling it a red alert, record low levels, and coming Colorado River's crisis. So that's kind of the media narrative, is it's getting pretty scary, and we're super concerned how to meet this challenge going forward. So there's a lot on this slide. I obviously don't expect no one should read this whole slide, but this is all to say that how we got to where we are on this river is over a century of treaties, compacts, settlements, legislative actions, international agreements, going back to 1922 when the first compact was developed for this river, all the way, and this is actually not super current. There's another agreement in 2019 and another one ongoing that I'll discuss. But this is all to say that we've made these incremental changes to how the Colorado River is managed over time. And this gets at the title of this webinar, Transformative Change Through Incrementalism. And if you look where we are today, which is a binationally run river with lots of stakeholder participation, consideration of environmental flows, that is pretty transformative compared to where we were, but it wasn't a quick and easy path. It was a long, incremental path to get to where we are. And going forward, we're nowhere near where we need to be. And that continued incrementalism, I think, will continue to get us in a more transformative system. So just to highlight what that transformation has looked like. So back in 1922, this is the bunch that first allocated the Colorado River. I think you'll notice right away there's a demographic issue with a representation. And so we have this very limited participation. These are just representatives of the 7 US basin states divvying up this big international river. And I'm oversimplifying that compact here, but this is the main, the crux of it. Basically, just it allocated a set amount of water to the 4 upper basin states and a set amount of water to the 3 lower basin states. This was the original framework for how the Colorado River was going to be governed. Flash forward to just a couple years ago, this was the most recent agreement, and you can see there's a big difference in terms of who's going to be there. The person at the podium speaking is actually from the Jicarilla Apache Nation, Native American tribe located in New Mexico, who he's been heavily involved in Colorado River negotiations. So much more expansive, much more participatory, in getting more and more input from a broader group of stakeholders. Again, this is we have a long ways to go, but how much has the increase in contributions from Mexico, from our Native American folks, from environmental groups to recreation groups. It's been this really shift towards a more collaborative, more open, more participatory process. And I'm not trying to say that it's done and we're in a good spot. Again, we have a long ways to go, but just showing how much it's transformed over the last 100 years to the point, and again, a lot going on in this graph. Don't look at the numbers specifically, but this is all to say, this is where we are with a very complex set of, and this is just reservoir operations, how those 2 big reservoirs are operated, but we have a much clearer idea of who's at the table, who's going to contribute, who's going to take less water and when. And so this just shows a combination of the LBDCPs, the Lower Basin Drought Contingency Plan, that's the Arizona, Nevada, and California. The BWSCPs, the Binational Water Scarcity Contingency Plan, which that's the US and Mexico. There's been historic binational negotiations between the US and Mexico. Mexico is now an active participant in Colorado River decision-making. Not historically, that has not been the case. And so you can see all the major users in the lower basin, all these numbers mean are shortages that they're going to take as drought conditions get worse, as reservoir levels come down. So again, don't look at the specific numbers, just look at, you see Mexico, the federal government, California, Nevada, Arizona, these major users of Colorado River water are agreeing to take shortages should elevation levels continue to get to pretty scary levels. So just showing that everyone recognizes they need to be active participants, and what that means for the Colorado River is actively taking less water from an over-allocated system. So like I said, there's been a long history of Colorado River decision-making, all those different compacts, treaties, negotiations, congressional acts have led to where we are now. There's a big one that's being renegotiated right now. So there was an agreement in 2007 that was only a 19-year agreement. So it's set to expire in 2025. And the negotiations for how to replace that with a more long-term set of governance arrangements is currently underway. And so it's a really exciting time for the Colorado River Basin because there's been this shift towards a more collaborative, more open negotiating process. And now that we have this big agreement being renegotiated, it's a great time for more and more folks to come to the table. It's particularly exciting. I'm optimistic about more tribal involvement. Like you said, the Native Americans have been historically pretty excluded from these discussions, but I'm hopeful that they're going to be more involved. From an environmental perspective, like my organization, we're hopefully going to be able to contribute more to this discussion. This is all to say, to get to the idea of SERIDAS, is having such a robust participatory process for a big international river like this, with this defined policy negotiation that will be decided by 2025 to set the table for the next 20, 30 years, is a great opportunity to look at sustainability. What does that mean? What does it mean to different stakeholders, different sovereigns, and how can we contribute to make sure that that over-allocated river that no longer reaches the delta, where certain groups have been historically excluded, can finally be at the table contributing to that discussion. So I'm pretty optimistic that the next few years we'll see a lot of great work coming out of the Colorado River Basin. So just to conclude with a quote from the book chapter for that myself and several colleagues wrote, we concluded with, there's a palpable sense of optimism and pride that such innovation is possible. It has emerged in recent years, even as reservoir levels remain dangerously low. So reservoir levels are dropping. If you look at the projections for the next 2 years, it gets pretty scary with Lake Powell and Lake Mead. But I think there is this sense of optimism. And I think as we come together to renegotiate this new policy, I think we're hopefully going to be in a much better spot, setting ourselves up for the next 20, 30, 40 years to be a much more sustainable system. I just want to acknowledge really quick the co-authors on this chapter. So Doug Kenny, lead author, and then Mike Cohen, and Regina Bueno, and myself. It was a great opportunity, and thank you to Jurgen and the team for letting us be a part of it. And thank you very much.
Thanks so much, John. Really interesting, although, we've all, of course, had our eyes on the heat wave and everything that's going on with Colorado and the water resources. So it's going to be interesting to see how it turns out. Hopefully it will be lessons learned for all of us. All right, folks, we have one more speaker, Dr. Jurgen Schmandt, the one who kind of brought us all together for this and started the SERIDAS. He's speaking to us today from the University of Texas at Austin. He's also a fellow at the Houston Advanced Research Center. Jurgen, you want to take us away, Scott? I think you're going to do the slides for him.
Thank you, Stephanie. I'm looking for my file. And
Jurgen, I think Scott's going to do the slides, so you should see them up on your screen.
it should be there now.
Yes.
Can you see it?
Yes, we can see it.
Okay. I would like to reflect on what did the 10-year program SERIDAS, of which we saw some examples today, what did it come to in its general conclusion on the future? Can we manage a sustainable river future, sustainability looking at both human needs and natural environmental needs, or can we not? Our definition, which is new, on environmental and social sustainability of river systems in dry lands, is based not only on the work of our own team, but also of the work of the Club of Rome and one of our rivers that is ahead of the others, the Murray-Darling River Authority. Let me briefly review those inputs. The Club of Rome, perhaps the biggest, most influential private organization to think about the future of the planet, starting 50 years back. The first big publication, Meadows, The Limits to Growth, 1972, obviously covering a much, much larger area, but considering our concern about water, irrigation, food, drinking water, he makes 2 points. The access to arable land has been a designing feature of human history since the days of early Egypt, early China. And this system will face a major shortage of arable land within the next 30 years, which would have brought us to the beginning of this century. Why? Because arable land is taken away from food production, away from farmers, and is used for industrial and urban use. The general recommendation made by Meadows, huge, stop population growth, which also would stop city growth. 20 years later, the second report by the Club of Rome, yes, we have enough water globally, but we don't operate it correctly, we pollute water, and this will mean we are reaching the limits of agriculture, of irrigated agriculture. What should we do? Control pollution, improve the way we distribute water and operate the water systems. The third assessment, 2004. Here he focuses on something that's very much at the heart of our SERIDAS study. Sooner or later, reservoirs silt up and they become ineffective. They lose storage. So they are in the future not a source of sustainable flow. What should we do? Most important, instead of flooding the field, shift to drip irrigation. Uses much less water, can result in the same food production results. Combat climate change. Big tasks. And then comes the 50-year Club of Rome summary. Now, excuse me, I made this on. Here's the 50 years in a title of a book entitled Come On. The dominant way of food production using water, irrigated agriculture, is not sustainable. Replace it by what they call agroecology, to preserve soil, water supplies, regenerate soil fertility, encourage biodiversity. On balance, what the Club of Rome in its 50 years has contributed, yes, they identify key challenges to use of water, world food production. They focus in their solutions proposed on changing farm practices. They say virtually nothing on how river governance needs to change. This was the focus of a book which we like, published in 2014, Brian Richter, reviewing the work already underway in Australia in the Murray-Darling River system. Principles are these: build a shared vision for your watershed, set concrete limits on consumptive water use, allocate a specific volume of water to each user, and monitor that this is adhered to. In all regards, practice water conservation, trade water entitlements, and the most revolutionary approach, subsidize, pay for if a user reduces his or her consumption. Now, what does this all add up to? Our work, their work. Number one, we like the Murray-Darling principles. Number two, there is one central concept we would like to propose. We call it the dependable yield. What is, under changing conditions, climate change, reservoir sedimentation, population growth, what is the dependable yield of the river? Make this measurement the yardstick for governance and administering your basin. Nature's water supply, averaged over the period of the most severe drought experience, delivers yield sufficient to meet human and ecological needs. To give you the details of this new concept, dependable yield, I advise you to read the chapter written by my colleague George Ward. All the technical details, how you measure it, how difficult to measure it, what you can do to improve your measurement skills in the organization, you'll find in this chapter. Second, while you work in rethinking, structuring your distribution system of power around dependable yield, you and your stakeholders, the groups that Aysegül talked about, constantly, proactively search for ways to use water more efficiently. What you then have to do is the tough part. Whenever the human or natural changes identified change the flow of water, you, the managers, and your stakeholders jointly, that's important, not one against the other, but jointly, adjust the rules for water allocation so that you are able to achieve your goals with the new level of adjustable yield, dependable yield. And then you have to think about ecology, environment. You have to devote more effort than it is currently done to define, maintain, restore a prudent level of in-stream flow. What we propose here is an uphill, tough battle in the policy arena. Existing management organizations of rivers use, as we have called it, the mirror looking at the past. They have to change their focus on the future. there are two examples which will improve water supply significantly. Each river has to improve the way in which surface water and groundwater are seen as a unity and how they support each other. Each river has to avoid water conflicts or resolve water conflicts. What does this mean for the organization of a management team? Number one, you have to make sure that your basin management team includes a scientific team that has the experience, the competence, the tools to determine and constantly update dependable yield. Number two, the river management organization, and this is a big if can it be done. The river management organization receives authority to rebalance, to change existing water allocations between agriculture, cities, and environment so that they meet the new reality. We propose one way to achieve these goals. There are other ways. Our idea is to have the management agency and the stakeholders jointly draft and then update in 10-year intervals a sustainability plan for the river basin. This plan uses dependable yield as the yardstick for both the technical assessment and for recommended actions. Ideally, and this is way into hopeful thinking, the sustainability plan becomes a public document submitted to, debated by, approved by Congress or Parliament. With this, I would like to conclude and make 2 points. Number one, we greatly appreciate the help of IWRA, in particular Scott, who made it possible for us at the point where we are concluding our work to inform a larger public about what we have found. Number two, it is extremely important to us that these findings be shared by not only the management authority, the stakeholders, but by the population at large. Thank you.
Thanks, Jurgen. That was great, and we really appreciate that. We have about 5 minutes before the actual end of the webinar. I want to thank the panelists. If everyone has looked in the Q&A on the actual webinar framework, our panelists have done a really good job of going through there and answering some of the questions that have been posed. We do have time for a couple of questions or discussions right now. I think one I'd like to take, and Aysegül, you spoke to this, and I think we'd like to hear from some of the other panelists on this, but how can one identify stakeholders? And I hear this a lot, like how did you really make sure you had a full representation, that you had diversity, that you had all the voices heard? So Aysegül, if you want to start us off, because you spoke to both the Rio Grande and Turkey, and then I think everyone could maybe speak to that as well.
Thanks. Yeah, it is easier to identify stakeholders when there are really establish institutions at transboundary and national and subnational levels. So it was easier to identify them in Rio Grande compared to the basins like Euphrates-Tigris Basin. So yeah, there has been such institutions existing in Rio Grande, for instance, since the treaty, the Boundary Commission, and also the ones which started voluntarily by the stakeholders. We mean the sectors like irrigation districts, the utility, the cities, and industrialists, but especially environmentalists or academia, and so forth, NGOs. So they started in Rio Grande some voluntary also platforms like, the Texas, the Paso del Norte Task Force. But in the Euphrates-Tigris Basin, the stakeholders have voices, of course, through such institutions that I talked about, irrigation associations, but they don't exist very well in other countries. And in Turkey, there is a drawback, actually. So they were more independent 10 years ago, but now more under control of government. And there are NGOs. In the chapter 18 in the book, I try to identify the NGOs in the Euphrates-Tigris Basin by emphasizing that they emerged morely after 1990s, after Rio Conference and so forth. And there are also industrial groups, private sector, so forth, but the picture is more chaotic in some river basins. And it depends on, as a researcher, how you identify them. And additionally, in Rio Grande, we had a chance to conduct a very limited but very enjoyable survey when I was in Austin, and Jurgen was leading it, and our graduate students were drafting it. So they conducted a survey through for the Rio Grande Basin, trying to figure out their priorities and how to cope with unsustainable management and so forth. So we had a practice, a short and a brief practice of identifying the stakeholders. But it's an actually endless endeavor. I cannot say we clearly identified in 9 or 10 river basins that we worked on. But I believe my experience shows that institutions are helpful to identify them.
Thank you, Aysegül. Does anyone else want to speak to that? Eduardo, if you, okay, you're on mute. Thank you.
Well, for us, it depends on the scale that we are talking about. I mean, if you focus on the big reservoirs, it's okay. It's a clear picture that we have the stakeholders right away identified. But at the local scale, we have a variety of situations that really can be a challenge because we don't have governance at the local scale. Just to give an idea, we have 155 monitored reservoirs managed by the state and the union. And at the same time, you have 105,000 small dams that we don't have any water governance, any institutions that have, how to say that, influence in managing this infrastructure and also licensing new infrastructure at this local scale. So I would say that is a challenge. We have to implement such a system that goes beyond the state. It has to involve NGOs, municipalities, and other private players.
Thank you, Eduardo. Scott, do you think we have time for one more question?
Yeah, absolutely. If everyone wants to stick around, certainly time for as many questions as you want.
Okay. And again, I'll just direct everyone's attention to the Q&A, and I really appreciate the panelists putting some answers in there, but I always think it's interesting if we can discuss some of these too. Another one that we had to do with, can the SERIDAS framework be narrowed to certain environmental changes, that is land use and land cover changes? And that is a really interesting question. And the short answer is yes, but I thought in particular, John, not to call you out, but I think you could really speak to how important that land use and land cover is when it comes to some of these modeling and forecasting.
Yeah, not sure I'd be the best to answer that, but I guess in the Colorado River Basin, at a local level, the land use changes are really important. That's a major driver of new demand.
Right.
And so what we're seeing throughout the basin is if you integrate water into that land use decision-making process, like I said, we have some of the fastest growing states in the country. If you were proactive about that land use change and what it looks like and how it's changed and what types of development you have with that land use, then you can actually not only use less water, but maybe save enough water to put it back in the river. So I think it is at a locally driven level, it can add up to basin-wide benefits that I think would help the river.
Great, thank you, John. And that's exactly what I was getting at. That local is so important. I don't know if anyone else wants to speak to that one. We do have a hand raised, Scott. I don't know if we can take that question. It looks like I can't, but.
Well, if they want to just put it down there in the Q&A box, we can.
That would be great.
Yeah, it'd be great if your hand raised, if you're the audience there, and
Okay.
maybe just raising their hand to say hello. I don't know.
They might be. They may not know they have their hand raised. I've done that before.
Yeah, just virtual fun.
Yes. Okay, so here's one more for the panelists and whoever wants to speak to this, but how much is the infrastructure in place the actual issue rather than climate change or any human right approach to secure water corridors or any environmental flow approach? Can someone speak to, is it a balance? Is it the infrastructure itself, the aging infrastructure that's the problem? Is it all these things on top of it?
I'll take a quick stab at it. It's all the things, right? We wouldn't be where we are today as a society in the Colorado River Basin without the infrastructure. Going forward, we need new institutional arrangements to better manage that infrastructure. Climate change is driving major problems that we already knew existed. It's just exacerbating and making them quicker. And so it's all the above. And I think what I've heard summed up as the fundamental challenge in the Colorado River Basin is we have 19th century water law, we have 20th century infrastructure, we have 21st century climate and population. So those three together, obviously, if we go back with a clean slate, we would do it very differently, but we have all those three things and we need to make sure we can figure out to work within that to transform the system so to get to sustainability. But you can't just ignore where like the context of all those things together, you have to address it and move forward.
Great, thank you, John. Anyone else want to speak to that on the panel? No? Okay. I think we have time for one more. Oh, here the hand raiser. Thank you very much. Any ideas on regenerative river reconstruction within the cities and urban areas? Since water basins cover larger areas, there is a trend for river rehabilitation in cities. Can anyone speak to that? I see some heads nodding. No?
I guess if no one else wants to, I'll just say that is the trend we're seeing in the Colorado River Basin. The rivers through western cities here in the western US used to be low value. They were like the dump, the garbage heaps. Everyone just threw their junk by the river. And what we're seeing throughout the river basin is, wait a minute, rivers are actually really cool. They're beautiful. They provide all these benefits. If we can clean them up, you have great access for folks to enjoy the rivers for what they are, to experience those riparian ecosystems and all that. So just to the person's question, I think it is a trend we're seeing, and it's a trend I hope continues for a very long time, because I think it's a really cool way to help people connect to their rivers.
James?
I'll just say that in the part of this region, we talked about China, but I live in Japan, and our association is going to have its Congress in Korea coming up. And I think in all three of those countries, urban river restoration is quite far advanced, particularly in Japan and possibly Korea. I'm not so sure about China, but China's doing some other things, such as the so-called sponge cities, where they're trying to make, to improve the water cycle so that the urban land cover does not impede it. So kind of get the water back in to the river and on its way down.
Thank you. Thanks, James. Thanks, John. One question, and I just, Scott, I want you to remind people, but it's, will you be able to see the session in a recorded way later? And the answer is yes.
Yes, we're recording it and we'll have it on our website, www.iwra.org, in a few days, quite soon.
Okay. Great, thank you. Here's one that hasn't been answered. Any migrants representation for water quotas and water corridors to vulnerable people? Has anyone had any experience trying to work with migrants as part of the stakeholder population and speaking to their vulnerability? It's a great question, and it's a rough one, especially, you know, in all our rivers, but I know in the United States, with the Rio Grande, with shared borders, it becomes very, very, very important that they are included in the conversation. We do have some cross-boundary organizations that I know in the States are trying to get there, but I will tell you, it is very much a learning journey. And I hope that we will be in a better position to actually have kind of that fair and equitable representation within even the next, 5 years or so, because there has been so much momentum going forward on that.
Yeah. A quick comment from my side, living close to the Euphrates Tigris Basin, though I'm in the west section of Turkey, but the Euphrates region, and as well as Tigris, it received like millions of migrants in the last decade and even more during the Iraqi crisis as well. So it's a huge challenge, but so far it has been tackled. First, the stability tried to be brought by the government entities, and then it has been tried to be tackled from upside approach, top-down approach, that the migration tried to be tackled by government interventions, trying to provide them water supply and sanitation. And yeah, the participatory approaches are trying to be tried through the NGOs, the civil society groups emerging in Syrian civil war. But it's, as you say, it's a learning approach, and this is a very difficult case to handle. But we are talking about millions of people. So when it comes to sustainable water management, we try to provide in our book, and an earlier article emphasized that first stability and good governance is necessary to apply sustainability in our river basins.
Thank you, Aysegül. Okay, I think we have one more here, and this was an interesting discussion within the Q&A, so I would like to bring it up to talk about, although I did just see one in the chat which hasn't been answered, so let's start there and then see what kind of time we have left. How can the stakeholders fix the dependable yield? Which parameters are included in the dependable yield? Jurgen, I don't know if maybe you want to talk a little bit about what goes into the dependable yield, the parameters that are included. I'm not sure if he can hear us. He had some problems with he had some technical difficulties earlier, so he may not.
I would like to bring the audience up to date on something a little different. We have often talked about that. What we presented today will be available in detail in the book Cambridge University Press is about to publish. 2 comments. Number 1, the information we had earlier that the book will be published next year is not consistent with what Cambridge University Press says on their website. On the website, they say it will be the end of July this year. And private sector is always better informed than academics. If you go to Amazon, you can order the book today and they send you an immediate reply saying, we are standing by to send you the book very soon. Thank you. Last point I would like to add, this book, Aysegül and I are listed as the editor, would never have come together in time and in the fashion it is getting together without the tremendous help we got from two of our graduate students, Virginia Bueno and Zefra Thomas. I like them very much, and they represent something that says the work of the SERIDAS team had one component that is not natural. Much of the work we did was really done by teams of graduate students and one or two faculty members. The example, Aysegül came to visit for a year at the University of Texas, and we assembled a team of 12 or 13, and we looked at specific water issues, including stakeholder involvement in the Rio Grande and in the Euphrates Tigris. Several projects of this nature involving the next generation were done, all of them published, all of them available on the web. So it was an extremely broad-based approach, way beyond the 4 or 5 people showing today. A good team, interdisciplinary, international. I thank them all.
Thank you, Jurgen. And I think that's a great note for us to end on. Jurgen's right. We had so many people helping through this process. So kudos to all. I can't wait to get the book. Scott, you want to close this out?
Yeah. Okay. Well, I didn't know if you were finished there. I agree. I can't wait to see the book. I think Jurgen was saying earlier, this is the conclusion of 10 years of work, and I think it really shows. I think it's really a great webinar and really a nice way to kind of sum up the work that this group's been doing. So really like to thank everyone on the panel here. Thank you so much today to John Berggren at Western Resource Advocates in Colorado, United States, Aysegül Kibaroglu in the MEF University in Turkey, James E Nickum, Water International Editor-in-Chief, long-standing, working with the IWRA, since Water International is our flagship journal for the IWRA. So Jim has been an integral part of IWRA for many years. Eduardo Sávio, the Research Foundation of Meteorology and Water Resources in Brazil, and Jurgen Schmandt at the University of Texas in Houston Advanced Research Program, USA, and of course, naturally, our great moderator, Stephanie Glynn, Program Director at the Houston Advanced Research Center. So some of the panel I know, and IWRA, we're all on Twitter, so go ahead and give us a look and give us a follow if you're interested. If any of these presentations left you interested in learning more, you can go over to our LinkedIn webpage and continue discussion. Follow us for more updates on IWRA. And just as a reminder, I think I've mentioned a couple times that we're going to have the recording and we'll have the presentations all up on our website, www.iwra.org, quite soon. So give us a couple days and we'll have it up there. So I hope everyone found the panel and the insights they gave us here today about their book really useful. Hope we gave you some material to think about in your work. And so please feel free to reach out and interact with anyone on the panel if you can, and kind of continue and bring this forward. So just to remind everybody, again, this is a webinar brought to you by the International Water Resources Association. We are a 50-year-old nonprofit, non-governmental educational organization. And we focus on bridging disciplines and geographies and connecting professionals, students, individuals, corporations, and institutions, everyone who's concerned with the sustainable use of the world's water resources. So if you're interested in learning more about the association or becoming a member, please go to www.iwra.org. So on behalf of the whole IWRA office, we thank you for tuning in and viewing the webinar. Thanks.
Bye.
Bye.
Thank you.
Bye.
Thank you.
Thank you, guys.
Thanks.